In order to build really robust control charts, we need to talk about how you choose what are the groups that you're going to group together. So when we choose the boundaries for our groups, what we want to do is we want to make sure that we group data with things that belong together. So generally, we group things by time or by where in the sequence they happen, or by which iteration we're working on, what shift is working on something. So basically what we're looking for is boundaries in the process, and we're going to use those as boundaries of our groups. So to show you why rational subgrouping matters, I've made some data that ought to look out of control. So I've gathered data for every hour, and I've done that for a grand total of 27 days. So there are 216 observations. And I have intentionally rigged this so that the first shift of every day gets bigger numbers than the other shifts during that day. So if you look at how, and then I group it by shifts. So there are 8 hours in a shift. Compute the average and the range for each of those shifts. And if you look at the average chart, you can see this spikiness where every third shift on general is doing better than the other shifts. Now this is something that we would really like to be able to detect as being out of control, because one shift is behaving differently than the other shifts. So if I look first at the range chart looks pretty in control. There's this one little warning thing, but with this many observations, that's not really surprising to me. But if you look at the results of the mean chart, it's out of control all over the place. And in fact, every 8th time it has high out of control, and it's so chaotic that it's showing out of control in other places too, because it can't really tell what the central tendency of this is. So when we group it rationally in 8-hour shifts, we detect the problem easily. Now on this sheet, I've taken the exact same data that I analyzed on the prior sheet, but this time I've grouped it 7 hours at a time instead of 8 hours at a time. So it isn't really a shift at all. It's just grouped 7 at a time. So it is not rationally grouped. In this case, calculate the average and the range. If you look, the chart is a little spiky, but not as spiky as it was before. The range continues to look reasonably in control. I may be a little, this 2 ranges next to each other might worry me a bit, but it looks a little out of control. And if you look at the mean chart, it looks much more in control than it did when we were grouping 8 at a time. And the reason this is, if you look, those first 8 are these 7 and that 1. So that 1 that is big is making the range of the next set look really big. And the same thing happens, because that shift that is getting bigger numbers than anybody else's shift is not all in one group. It kind of oozes out into the groups around it, and that makes the charts much less sensitive to the differences that shift has. So when we group things, what we want to do is we want to group things that are similar so that we will have low in-group variance. And we'd also like to group things so that the boundaries in our process are the boundaries in our groups, because it is those places where things are most likely to be different. And so we would maximize between group variances. So if we don't group rationally, then we would have high in-group variance, and that's going to make the average range big, which is going to make our control charts not very sensitive. On the other hand, high between group variance means that different samples are likely to have different ranges, which will make that range chart detect out of control. Or high between group variance might mean that the means of different samples are likely to be different, which would make the mean chart detect out of control. So rational subgrouping is grouping based on the boundaries within our process, and it has the effect of maximizing between group variance and minimizing in group variance, and this is going to make our charts more sensitive to things that are out of control.